Honest Andy's Discount Moon Show! Hello and welcome to show 27 of Honest Andy's Discount Moon Show, recorded on the 15th of November 2021. My name is Andy, the self-appointed moon expert, and I'm here with Rick. And on today's show, we're going to talk about the moon has oxygen, but how much oxygen does it have? Then we're going to talk about the quasi or near-Earth asteroid Kamo'oalewa. Then we have some foreign moon news, which is basically a new moon alert bonanza, talking about the large asteroid Elektra, some new moons of Saturn, and an interesting discovery about the dark side of Pluto, thanks to light reflected off Charon, Pluto's largest moon. And we'll also talk about the moon is made of cheese. Where did this phrase come from? And ending on PriMOOnisters Questions. But without further ado, Rick, how are you doing?
I'm doing well, Andy. How's things with you?
Oh, not too bad, not too bad. Even though that the stock phrase now is, "Oh, isn't it getting dark early?" It is getting dark early, and I think everyone's starting to feel a bit moody because of the shorter days, colder weather, and persistent onslaught of Christmas.
Yeah, that's right. You go to work, it's dark. You come home, it's dark. Work steals all your daylight.
Yeah, it does. I remember when I was commuting and I compared it to like one of those child miners that I heard about in Victorian times. They were like, oh yeah, the children would get up so early and come back so late they wouldn't see daylight. And that always kind of stuck with me. I feel like a Victorian child miner going to work at the moment, sitting in my comfy chair in my nice heated office and the trials and tribulation of Andy, the child Victorian miner.
Yeah, I bet if Victorian children were alive today, they would be looking at you with your sipping your cappuccino and going, poor Andy, poor Andy.
Yeah, thankfully I work from home now, so I don't have to commute and I can actually go out when there is a bit of daylight.
No rickets for you.
So what have you been up to since we last spoke?
I'm just looking at my calendar. I did Wallaby Bins, God of Carnage, Hairspray, or Power Outage. Which one of those do you want?
The first one sounds like an episode of Timmy Mallett's Madhouse. What was that?
I'm just trying to work out what was Wallaby Bins. Oh, yeah, it's I put my neighbour's bins out. Oh. They're away on holiday. And I've spelt their name in such a way it looks like Wallaby.
Okay, that is not exciting. What was the next one?
Really? You're going to gamble, eh?
Yes.
Okay. Higher than Bins, it's God of Carnage. I went to see God of Carnage at Cheltenham Playhouse, which was an Amdram production yours and my friend Grant was in.
Oh, nice.
So, yeah, that was really good. Good comedy. It's a sort of mono scene, one act. Yeah, one scene, one act, i.e. no interval.
Yeah.
And it goes on for an hour and a half, and it's about four people, which are two couples, and one couple goes over to the other couple's house in an evening because their children have had a fight, and chaos ensues.
Okay, that sounds quite good. Well, I know what Grant is like. What was it, God of Chaos or God of Carnage?
God of Carnage.
Yeah,
it's good fun.
That's quite an apt title for a play featuring Grant.
Yes, indeed. So, no, it's good, because obviously it starts off saying, oh yeah, we'll all get along, don't worry. And, spoiler alert, invariably they don't.
Oh.
Would you believe? Incidentally, in Jurassic Park, the dinosaurs escape.
What?
So, yeah, that's what I've been up to.
Nice. That sounds quite nice and cultured, of going to the theatre. I went to see... what have I seen in the cinema recently? I've seen the new Bond film, seen Dune, and Edgar Wright's new film called Last Night in Soho, which was really good. But I wanted to like it more than I did, because I really like his stuff. He's the guy who directed and helped write Shaun of the Dead, Hot Fuzz, World's End, and then he did his own films with Baby Driver, and he directed Scott Pilgrim vs. the World, but I really wanted this film to be spectacular because it's like set in the 60s in Soho, but it was just a little bit clunky, unfortunately. But I still enjoyed it.
Oh, I went to see James Bond. I'm to see Dune. Don't spoil that, but I have seen the first film, so I pretty much know what's going to happen.
Have you read the book?
No.
Okay. I haven't read the book, and I haven't seen the first film, but I very much enjoyed Dune. And this is not a spoiler, this is just a comment on the effects of the film. I remember my dad describing how blown away he was when he watched the first Star Wars film and the opening scene of A New Hope, where you have the tiny rebel ship being pursued by the Star Destroyer and just the huge spaceship engulfing the screen, and you get a sense of scale of just how big these spaceships are. That's exactly what you'll experience when you watch Dune. It really is spectacular.
Oh, brilliant.
So watch it on the biggest screen possible if you can.
Okay, I will go to a cinema.
Yes, please do that. So, do you know what rhymes with Dune?
Prune.
Guess again?
Is it Honest Andy's Discount Prune Show?
No.
Oh, no. Moon.
It is indeed moon. Oh, should we talk about some moons?
Indeed we shall.
Yay! So we start off the show with some moon news, and one of the articles that caught my eye this time was the moon has lots of oxygen, but how much oxygen does it have? Well, apparently there is enough to keep billions alive for 100,000 years.
Hang on a minute, Andy.
Yep.
So, in my role as a moon non-expert, I know it's fact that the moon doesn't have oxygen, because if you get out of your capsule and start breathing, you will die.
This is true. You will die, and that is because the moon doesn't have an atmosphere. But there is oxygen on the moon. It just doesn't happen to be in gaseous form. It is instead in rocky form, or in a chemical form within the rocks, on the surface and below the surface. Okay, moon non-expert. Do you know what I mean when I say the moon's regolith?
No, I've forgotten since last time.
Okay, regolith is the surface of the moon, the soil. Although an interesting point that they made in this article, because it's written by John Grant, who is a lecturer in soil science in Southern Cross University, and he says, some people call the moon's surface layer lunar soil, but as a soil scientist, I'm hesitant to use this term. Soil as we know it is pretty magical stuff, and it only occurs on Earth. It has been created by a vast array of organisms working on the soil's parent material, whereas regolith is derived from hard rock over millions of years, so it's devoid of organisms. Well, it used to be until some stupid person launched a bunch of tardigrades at it, but that's by the by. But I thought that was an interesting term, that soil is kind of like reserved for Earth.
Yes, I've not come across the difference between soil and regolith before, and I rarely need it in everyday conversation, I'll be honest, but if it ever comes up, the soil gang versus the regolith crew outside my house on a Friday night, I'll be able to solve their arguments, instead of them having to beat each other up with beer bottles.
But make sure that they recycle the beer bottles afterwards and put them in the correct recycling bin next to the wallabies.
Oh, yeah, absolutely. After COP26, the local motorcycle gangs are really environmentalists now. So all the oxygen is in the, not soil, but regolith. So does that mean I can sort of snort up the soil through a straw and I can survive because it's full of oxygen?
No. Not unless your body can conduct electrolysis, which is the process of applying an electric current to a substance to separate out certain chemicals and elements from it. In this case, electrolysis is often used in aluminium oxide. Oxygen is a byproduct of it. You apply electricity to aluminium oxide and it separates out the aluminium and the oxygen to kind of purify aluminium oxide raw material in order to get aluminium out of it. So unless your body could do that, which I don't think it can, you're not going to be able to get the oxygen out of the soil. So how much oxygen is there? Well, they said it's enough to keep billions alive for 100,000 years. What they're talking about is the oxygen that is contained within the lunar soil, or the materials and the rocks that are on the surface of the moon. So this soil scientist has done some back-of-the-envelope calculations with the following assumptions. Just looking at the moon's surface, so ignoring the oxygen that is way below the surface that is quite inaccessible, and just looking at the first 10 meters of lunar soil, each cubic meter of lunar regolith or lunar soil contains 1.4 tons of minerals. And on average, 630 kilograms of that 1.4 tons is oxygen. Now, according to NASA, humans need about 800 grams of oxygen to survive for a day. So out of that 630 kilograms of oxygen, you could get enough oxygen to keep a person breathing for 2 years. So, mining all of the oxygen from the top 10 meters of the moon's surface would provide enough oxygen for 8 billion people for 100,000 years.
That's pretty good.
Yeah, that's quite cool, but this is assuming all of this oxygen is set aside for breathing, because we have mentioned in the past that separating out hydrogen and oxygen from H2O, from water on the moon's surface, is very good for rocket fuel, because you need oxygen and you need hydrogen. So That's assuming all the oxygen is going to go into breathing.
Oh, that's good. We'll be living on the moon in about 3 years.
Well, yes, yeah, easily, because NASA did say that, oh, no, wait, no, it's been pushed back, hasn't it? There is a startup working on this, actually. A Belgian-based startup called Space Application Services announced it was building 3 experimental reactors to try and improve the process of making oxygen via electrolysis. Now, the problem with electrolysis is it requires a lot of electricity, which requires a lot of heat, which requires a lot of energy, which is all well and good doing it here on Earth, but having to do it on the moon would take a hell of a lot of infrastructure, and we've discussed before about how vital it is to keep cargo to a minimum because of the fuel costs of getting from Earth to the moon. And this isn't a case of, oh, fuel is expensive, it's a case of, no, you need a lot of fuel to get a small amount of weight off the planet. So this Belgian-based startup is trying to make electrolysis much more efficient and a lot smaller as well.
Brilliant.
Maybe invest in them.
Yeah, when do they expect to actually get one working and send it to the moon?
Well, they'd like to get one done by 2025 because that's when the European Space Agency, or ESA, is going to do something called In-Situ resource utilisation. So they're going to send up a bunch of experimental stuff to the moon to see if it will actually do what it's supposed to do. So in this case, can we get oxygen from the moon rocks by applying electrolysis to the surface? There's probably going to be another one to do with water extraction. There's probably going to be something to do with radiation and how much radiation is absorbed on the moon's surface because there isn't an atmosphere, or a magnetic field to kind of divert the radiation from the sun. So if you stand there, you're just exposed to the solar radiation, which is quite bad.
This reminds me of, do you remember doing chemistry, GCSE chemistry? And you used to do some sort of experiment, electrolysis, and collect the gas. And then the teacher would say, that's oxygen, that is. And you'd say, well, how do you know? And the teacher would say, light a splint, put it out, and then stick it back in the oxygen, and it will relight again. Did you do that?
Yes, we did. I'm not sure if it was that experiment, but we did one where it was hydrogen with the squeaky pop.
Yeah, each gas had this, quite frankly, non-scientific explanation as to what a lit splint would do in it. So yeah, I'm just imagining all these robots on the moon in about 5 years' time, all with lit splints, arguing over, is that hydrogen or oxygen that you've created?
There's the one robot designated with the lighter.
Yeah.
No, there you go. It would be Sergeant Bash. So send up Sergeant Bash with its flamethrower. That's in charge of splints.
So after all these robots have created a lot of oxygen, presumably it's going to end up in the atmosphere. So would the moon eventually have an atmosphere?
No, because it doesn't really have a way of holding on to it. I mean, it's a pretty big, dense rock, but I don't think that gravity is enough to hold on to the atmosphere. Plus, not only that, there's no way of replenishing the atmosphere. So once it leaves, there's nothing to replenish it because the robots are not going to stand there flicking the lighters over and over again to generate the gases. That's not enough to sustain an atmosphere. We might cover this later on in one of the PriMOOnisters questions, but moons like Titan have an atmosphere because they're big enough to hold on to it with the gravitational pull, but there's also a way of replenishing the atmosphere. There's enough going on the planet and enough processes in place to replenish the atmosphere that leaks out into space.
Okay, so it'll just be like one of my parties then. No atmosphere, very few people in the first place.
It's talking to chain-smoking robots. Good news, Rick.
What's that?
The Earth has a new moon, quasi-moon thing.
What is it this time?
Actually, this one has been around for a couple of 100 years, and it's actually been observed recently, and it's thought that this quasi-moon, or near-Earth asteroid, is indeed a fragment of our own moon. A frag-moon, if you will.
Is that a proper scientific term, or...?
Nope, just made it up.
Okay, right.
So this near-Earth asteroid is called Kamo'oalewa, and it's an asteroid that's only 41 metres in diameter, and it's currently the closest, smallest, and most stable known, as in we only know of this one, quasi-satellite of Earth. Now you're probably thinking, what is a quasi-satellite of Earth?
Yes, I was told that the word quasi means almost and might as well be.
Yes, pretty much. So if you were to take a frame of reference, so imagine bird's eye view of the Earth, and you're looking down, and you'd be able to see this quasi-satellite orbiting in like an an oval shape about 9 million kilometres away from the Earth. So it's pretty... That looks like it's orbiting the Earth, right? But if you take a bigger step out, and now the sun is your frame of reference, and you see the Earth going around the sun, you'd still see Kamo'oalewa orbiting the sun as well. And what's happened here is that the Earth is orbiting the sun, and this asteroid is orbiting the sun at the same time. We're on the same path, and occasionally this asteroid will be a little bit ahead of Earth, and then it'll be a little bit behind Earth. So imagine you're on the motorway, and you're in the middle lane, so someone overtakes you on the right, goes in front of you, comes over to your left side, slows down, and then it goes behind you, and then overtakes you again. They've done like a circle around you, haven't they? But if you were just on the side of the road, you'd just see two cars going in the same direction. They just happen to be on the same path. One is just doing circles around the other. That's what this asteroid is doing, making it a quasi-moon. So it's in theory orbiting the Earth, and the gravity of the Earth is affecting it, because when it gets a bit ahead of the Earth's gravity pulls it back, and when it's trailing behind the Earth's gravity pulls it forward again, kind of like slingshot it. But the reason it's not in a proper orbit and it's not a proper moon is because this has only been happening for the last 100 years or so, scientists predict, and it will be stable for a couple of 100 years, but it's not going to last forever. And it's outside of the Earth's hill sphere, which is kind of like its capture radius. So anything outside of that is going to be affected by the gravity of the Earth, but not enough to capture it for good.
Okay, that sounds good.
And, very helpful for this podcast, there is a video I've included in the show notes. So if you want to have a look and see if what I've described is accurately represented, please have a look.
Brilliant. It sounds as though if you go out on an evening walk and you're going at the same pace as someone else, and you kind of go, look, this was my path, can you go away? And it's all right if you go in different speeds, because either they disappear off into the distance or you overtake them. But it's when you're going at the same speed, it's really awkward.
Yes, especially when you're like, all right, see you later, and then you're walking in the same direction.
So I think because we're bigger, the Earth, we should get primacy, and it should just be sent off to go and find a different planet to annoy.
Well, this could be our fault in the first place.
Oh, right.
Because this comes to the next question of why could it be a bit of the moon? So it's thought that because the moon is covered in craters, there's been lots of impacts on the moon, and it's thought that this little asteroid is actually a chunk of the moon that was exploded off during an impact on it hundreds, maybe thousands of years ago.
And why is that our fault? I blame the moon.
Well, we have a greater gravitational pull than the moon does, so we will have attracted whatever hit the moon to the moon from us.
Oh, fair one, yeah. So is it like, the president was going to be shot, but the bullet hit the bodyguard, and the bodyguard is the moon?
Yes. Let's go with that analogy. Yeah, that's a fair analogy.
The moon steps in going, no!
So how do they know that this is a bit of the moon? Well, when it was observed recently, they were able to look at the light that was reflected off Kamo'oalewa, and the light spectrum, the light curve that was reflected off it, is virtually identical to the light curve of the moon. And when they compared it to other near-Earth asteroids and other asteroids that are in the same orbital vicinity, there was no match at all, or no good match at least. So it's pretty clear cut that this asteroid, Kamo'oalewa, is from the moon. And this will make it the first lunar asteroid discovered, because there's been lunar meteorites. We found almost 500 chunks of the moon here on Earth, which have all resulted from impacts on the moon, sending debris up into space, and that's rained down on Earth. And we know it's from the moon because we've able to sample it and compare it to the Apollo samples, and there's a match. But this will be the first asteroid that has originated from the moon. So it's the first lunar asteroid, which is pretty cool.
That's brilliant. I'm just looking at the show notes here. Have they narrowed the time frame for the event to have occurred? And now I'm looking for a very narrow window.
Okay, remember that the...
No, I mean, they've used the word narrow.
Okay, but the moon is probably 3 and a bit billion years old.
I mean, by narrow, I mean like half an hour leeway.
hang on. How?
If I meet you at the cinema, I want you to turn up within half an hour.
Okay, I know what you're getting at here. The time frame is 100,000 to 500 years. So there is a discrepancy there of 95? No, wait, of 99,500 years. But
Not narrow.
that is quite narrow compared to the age of the moon, which is 3 to 4 billion years old. Actually, no, I've Googled it and it's 4.5 billion years old.
If I agree to meet you at the cinema and you turn up 99,000 years late, I'm going in. I'm just going to get the popcorn myself and going in.
You'll just miss the first third of June, though.
Yeah, that's it.
Now we're on to foreign moon news, where we talk about moons that belong to other planets or other celestial bodies of the solar system. And I've got to thank N3 in the Discord server for this one. There's a new moon alert!
Hey!
Hey! So, a large outer main belt asteroid called Elektra has 3 moons, making it the first quadruple system discovered and imaged in the main asteroid belt. So the main asteroid belt is the asteroid belt between Mars and Jupiter, and a large outer main belt asteroid just means it's a big asteroid that's on the outskirts of it heading towards Jupiter, making it outer. Inner would make it closer to Mars. And this asteroid called Elektra, or 130 Elektra, has got 3 tiny moons orbiting it. The first was discovered in August 2003 and was announced a couple of days after the photos were taken. The second was announced in August 2014, again shortly after the images were taken. And this moon was only announced recently on the 6th of November 2021. However, that was when they were researching and looking over the images that the second moon was discovered in. I think they must have just come back to this other moon with some new imaging process techniques or decided to give it another bash. And during this additional research, they found a third satellite, which is pretty cool. And these moons are tiny, by the way. Let me get up some statistics for you.
Yeah, they can't be that big, because I'm guessing an asteroid in the asteroid belt is not as big as a planet.
No, it won't be. So Elektra is 200 kilometres across. The biggest moon of Elektra is 6 kilometres across. Then the second one that was discovered is only 2 kilometres across, and this recent third moon is 1.6 kilometres across. And they're also incredibly faint and hard to detect because Elektra is a very bright object. It's quite like Ceres in its comparison. Ceres is a dwarf planet within the asteroid belt. Because it's got such a shiny surface, when you take a photo of it, the light reflects off it quite a lot, and it blurs the image around it, so it makes it a little hard to search for moons, especially when they're tiny. Like, this is less than 1% of the size of the object it's orbiting. And the reason why they were only able to discover this recently is because large telescopes with adaptive optic systems and advanced imaging process techniques are required to study the satellite's property. So it's only thanks to the advances in technology that we're able to discover tiny little moons like this.
Oh, cool.
These moons currently don't have a name. Now, Elektra is quite a cool name, and it's named after an Avenger from Greek mythology. I don't know if that means they were recruited by Tony Stark or something like that. But I was looking at what could you call these moons, because they currently don't have names. And I was thinking, well, maybe if Elektra had like a famous sword, like how, I was going to say Gandalf has a famous sword called Shadowfax, but that's not true. Shadowfax is the name of his horse.
Yeah. Do you mean King Arthur?
Yeah, King Arthur with Excalibur. So if there was an asteroid called Arthur and it had a moon, I'd call the moon Excalibur.
Or indeed just three sub-things.
Yeah, and one of the things that I was thinking these moons could be named after is the fact that Elektra is one of the most popular mythological characters in tragedies, and she is the main character in 2 Greek tragedies and has been the central figure in plays by various different authors such as Alfieri, Voltaire, Hofmannsthal. So you could name the moons after authors who have included Elektra in their plays.
Yeah. That'd be good.
I think that would be a good little nomenclature because it's a system, so it kind of warrants its own naming convention. What would you name them?
Sorry, I'm just quickly looking up Elektra. I was like, hang on, that's not a Greek thing. So it's all right. Yeah, it is an Avenger. I've somewhat of a pariah in my family, especially with my nieces and nephews, because I've never seen one of these Marvel films.
Well, I've seen a few, but I don't like superhero stuff. It's like how I haven't seen much Star Trek, but I'm aware of it through osmosis and just pop culture references.
Yes. There isn't actually a Wikipedia article on Elektra.
There is. Let me send it to you.
There? She's got 3 bibliography references on Wikipedia. so maybe they could name the 3 moons after them.
Sure, why not? And look, we've just got the occultation of citation needed. I think this is actually pretty cool that it's a quadruple system that's between Mars and Jupiter, and the fact that an asteroid 200 kilometres across has enough gravitational pull to keep another rock that's 6 kilometres across, almost 1,500 kilometres away from it, and keep it circling. I think that's quite amazing, especially considering how much other stuff is going on in the asteroid belt. You've got Jupiter to one side of it, the Sun to another, but it's still able to hold on to these little moons and create a system within it. I find that fascinating.
Yeah, it's like an ant holding on to tiny bits of grains of sand in a hurricane or something.
Yeah, but it's still able to do it.
Yeah, it's pretty impressive.
Yeah, good for you, Elektra. Alright, so we're going to move outwards from the asteroid belt to Saturn, and we're going to completely blow that moon news out of the water because I have new moons alert.
Hey.
So this paper has been floating around for a while now, but in a recent survey using the Canada-France-Hawaii telescope, Edward Ashton, Brett Gladman and Matthew Bedoin have detected 120 objects in that bit of the sky which were co-moving with Saturn. So that heavily implies that they are irregular moons. Now, out of these, a lot of them were known objects, which means they expected to find moons there, but a lot of them were not known. So they're like, okay, so this could well be a new moon orbiting Saturn. So extrapolating out from the bit of the sky that they were looking at and just going like, well, if it's that much in that bit and we have another 4 bits of Saturn's sky to look at, let's multiply that by 4 in a very hand-wavy kind of motion. And they've said that they estimate there are 150 plus or minus 30 moons that are above 2.8 kilometres in diameter orbiting Saturn. So officially, Saturn has 82 moons, but because of this discovery, and they need to be confirmed in follow-up observations, Saturn could well have 150 plus or minus 30 moons.
Better get naming then.
I know, I've been trying. I've been pestering them. I helped them with the naming video of like, hey, name Saturn's moons, and they still haven't announced it yet. They've assigned moons like Saturn LV3 or something like that, and that's usually an indicator that they're gonna name them soon, but there's still loads that have yet to be assigned a name.
What were the naming rules for Saturn?
Oh, what were the naming rules? Okay, so the general theme is giants. They have to be named from giants from Greek mythology, but there's lots of orbital groups. So there's the Inuit group, the Gallic group, and the Norse group. So within each of those, you want to name them from giants from those mythologies. So within the Norse group, giants from Norse mythology. Thankfully, there's loads of them. They are known as Jotun. The Inuit group, they want characters from Inuit mythology, ideally giants. But the problem is, when I was looking through the Inuit group recently, I think they're fictional, as in they were made for a children's book, but heavily inspired by Inuit mythology. But I don't think they are actually referenced in Inuit mythology. I do need to read it up properly. This was just from a quick read a while ago. But there are plenty of giants in Inuit mythology, and the other one is Gallic or Gaelic. So that's from Celt mythology in Wales, Scotland, France. So just from Gaelic and Gallic mythology, you want giants from there. And thankfully, again, there's quite a few of them.
So would Hagrid count?
No, he is forbidden. You can't have established fictional characters from books and TV, even though they have just completely violated that rule with the Inuit mythology one of, oh yes, they are from a children's book, but I think it might be heavily inspired by real ones, so therefore it's allowed, whereas I don't think you can point to a certain Gallic god and go, ah yes, that's Hagrid.
Right, so it has to be made up, but we don't know the author who made it up, because I'm assuming like mythology is made up.
Yes.
So it has to be a different kind of made up.
Correct. Okay, stop pulling apart this argument. You're right. And
what about a green giant? Which mythology? Because he's made up by marketing executives.
That one is explicitly forbidden. They say it can't be a mascot and it can't have any copyright involvement. Like, there can't be any copyright or anything that promotes a brand. Anything like that is forbidden.
Oh.
So I don't know how they got away with Titan, because there's so many companies called Titan.
Yeah, I mean, well, that's one way to do it, though, isn't it? Wait till it's named and then call your company after that.
Do you know any giants from Gaelic mythology? Because I was going to say Norse mythology or Inuit mythology, but I'm guessing you don't know any giants from those. But Gaelic, you might have a bash at that. Do you know any?
Is Gogmagog one, or is that's from the Bible? Can't remember.
Gogmagog, that does sound familiar.
Gog and Magog.
I've got Gogmagog Golf Club here.
Yeah, mythological golf club.
Oh, no, you're correct. Gogmagog was a legendary giant in Welsh and later English mythology. So yes, there you go.
Oh, brilliant. Right.
The giant was an inhabitant of Albion and was thrown off a cliff during a wrestling match with Corneus, a companion of Brutus of Troy. Gogmagog was the last of the giants found by Brutus and his men inhabiting the land of Albion. That's interesting.
There you go. I knew a giant all along.
Yeah.
Interestingly, there's a Gog and Magog article as well. That's the one from the Bible.
Oh, okay. I didn't know that.
So not to get your Gogs and your Magogs confused there, in case the Gog and Magog podcast get onto us.
That I've heard they're notoriously litigious. And so we now go into the outer reaches of the solar system, where we talk about Pluto and Pluto's largest moon, Charon. This article talks about a new image which has been released recently, and it shows the dark side of Pluto. So New Horizons, when it flew past Pluto, we have these gorgeous images taken of it, and the reason why they're in such great detail is because they're illuminated by the sun, and it was taking photos on the illuminated side as it flew by. But it was only there for a brief amount of time, and it got within 8,000 miles of the surface, and then it flew over it, and as it was departing Pluto, looking back on Pluto with the sun behind it, it took some photos, hopefully trying to get some information, but it was just like quickly snapping a photo. It's like, imagine you're in a car and you see like something amazing happening on the side of the road and you just whip out your phone quickly, be like, oh, we managed to take a photo quickly, and it always comes out really blurry. But you never know, you might have got a good one. That's what was happening here. Now, when they looked at the photos, they were awful. They were oversaturated because the sun was so bright, and the atmosphere of Pluto created this halo around it, and you had this big bright light, Pluto blocking it, and all of space, this big black void. So it was hardly going to have a very detailed view of the dark side of Pluto. One of the researchers described it as, it's like driving in a car with a dirty window, looking into the sun without a sun visor and trying to read a street sign, which is quite a good description. But they've been processing these images recently, and thanks to the light reflecting off Charon onto the dark side of Pluto, they're able to process some detail of the surface, and they were able to pick out certain dark points. They were able to see a difference between the North and South Pole, so they were actually able to get a glimpse of the dark side of Pluto because it was illuminated by moonlight reflected off Charon, which is absolutely incredible.
That's amazing, yeah, because that's miles away.
Yeah.
Yeah, just to be too scientific there.
It is quite far.
Yeah, because if you think about it, like on Earth, you can read, say, a newspaper by moonlight.
Yeah, I was gonna mention this because you talked about that in a previous episode, that you were able to read by moonlight.
Yeah, so you can do that, but we're relatively close to the sun. But what's going on here is it's miles away from the sun because it's by Pluto, bouncing off the moon onto Pluto, and then it's bouncing back off into a satellite.
Yep.
That's going at thousands of miles an hour.
Well, the satellite is actually going at 9 miles a second.
Okay, yeah, that's...
And not only that light has to compete with light from the sun, it has to compete with the atmosphere of Pluto creating this big halo around the planet. So they had to process the images and kind of get rid of the oversaturation. So I'm going to read a little paragraph from this, and because you've done image processing, could you put it into layman's terms for me, please?
I'll give it a go.
Okay, so it took a combination of 360 images of Pluto's dark side and another 360 images taken with the same geometry but without Pluto in the picture to produce the final image with the artifacts subtracted out, leaving only the signal produced by Charon's reflected light.
Give us a second. I'm not quite sure, to be honest.
What they've said here is the team had to rework the mission's data processing procedure to eliminate the parts of the images that were overexposed by sunlight and therefore didn't contain any useful data. Once those parts of the images were cleared away, the researchers could manipulate what remained to see the moonlit surface of Pluto. And that's when they took the combination of 360 images of Pluto's dark side and the other 360 image with the same geometry without Pluto in the picture. So the way that I am interpreting this is you have a Pluto plus mess, and then you have photos of same mess. So then you're able to go, right, subtract mess from Pluto plus mess, and therefore we just have Pluto.
That's what's going on. I'm not quite sure how they took a picture of the same geometry but without Pluto. What's the geometry?
Sky around Pluto, I think.
Okay, yeah, as in space.
Yes, space.
Right. Yeah.
Because it's going so quickly at 9 miles a second, they'll have lots of images of backlit Pluto, dark side of Pluto, but then the camera will tilt away and just take photos near Pluto, but not containing Pluto. So it will still have the same light data, but without Pluto there, so you can have... It's kind of like removing background noise from chatter. So if you just have us talking in a room and just record the background noise, there are some noise suppression software that allows you to subtract one from the other.
Yes, I was going to give that example, so yeah.
Okay, good. I'm glad that we got there in the end. And again, we're talking about an image on a podcast which is not very useful, but the process involved and just what is actually happening here is absolutely spectacular. Do you want to click on the image and have a look at it?
Yeah, that looks good, doesn't it?
So considering that Pluto is 6 billion kilometres away from the Sun, that light has travelled 6 billion kilometres, bounced off Charon, bounced off Pluto and into the lens of a camera, which was then beamed back almost 6 billion kilometres back to Earth.
For us to misinterpret it and get confused. And this is of the dark side of Pluto.
Yeah.
But I'm just imagining this is a very weird way of taking a picture of your ass.
So if I were to ask you what is the moon made of, what would you tell me?
Regolith.
Yeah. Yes, that is the correct answer. But if you were to stop a layman on the street, what jocular answer might they give you?
The moon is made of cheese.
Yeah, the moon is made of cheese, and this has been popularised by the likes of Wallace and Gromit and all sorts of wonderful cartoons and comics and stories. But where did this come from? Where did the idea that the moon is made of cheese come from?
Idiots.
Yeah.
The medieval equivalent of anti-vaxxers.
God. Yes, let's go with that. So... yeah, you're right. This has been around for a long time, and it's always existed in different stories. One of the first was variations of one animal tricking another. For example, a fox being chased by a wolf convinces the wolf that the moon reflection in the water is cheese, and to get the cheese, the wolf has to drink all of the water, and when it does so, it drinks too much water that it bursts, and the fox got away with it. So that's like one of the first mentions in folklore like that, in tales like this, that the moon is made of cheese.
I didn't know, like, wolves really wanted cheese that much.
Yeah, I think wolves are just hungry.
You really want cheese there? Drink a lake.
I mean, I could drink a lake, or I could just keep chasing this fox. I am bigger and faster.
Well, that's... yeah, in the time it's taken the fox to explain it, it's like, well, you could have eaten the fox.
Just chasing. Hang on a minute. Whoa, this fox has something to say. I better stop.
That wolf deserved all that it got. It's just not ready for the world of natural selection.
No, it's ready to be bred into a pug. But that is through folklore and just like passing down tales. The first time that this was actually written down and mentioned was "the moon is made of green cheese," which was a popular proverb in the 16th to 17th century in English literature. When I say 16th century, I mean the 1500s. I always get that confused. Whenever anyone says 16th century, I immediately think 1600s, but no, it's the 1500s. And it's likely this proverb was popularised thanks to the Proverbs of John Haywood, and he claimed that the moon is made of green cheese, and green in this case means old, because it's green with an E on the end of it. By the way, this book also contained some of the famous phrases we use today, like "the more the merrier" and "many hands make life work."
Oh, cool.
Yeah, but that's the first time it was written down that the moon is made of green cheese in this proverb book from 1546. And then over the centuries, this just became a common phrase to use when you're talking about someone who's being gullible. So you say, you may as well persuade someone that the moon is made of green cheese. And that's where the phrase came from, that the moon is made of cheese, but also to look at it as well. It's got the same texture of a big block of mouldy cheese.
Oh, okay. But it's changed from green meaning old to green meaning mouldy.
Well, yeah, pretty much. So one of the things that I was thinking about was, okay, let's assume the moon is made of cheese. What cheese would it be? And this is one of the things that I spoke about on Radio 1 when they invited me on the first time. And they were like, okay, if the moon is made of cheese, what cheese would it be? And my back-of-the-envelope calculation was to go, okay, let's look at the density of the moon, and let's look at the density of different cheeses and find out a good match for it. And I think the one that I came up with was Gouda or something like that. I forget which one it was. I wanted it to be Brie, but that's too viscous and not dense enough. But that is the wrong way to do it. That was the wrong unit of measurement to compare materials. And apparently, according to material science, the correct way to do it is to look at how the speed of sound changes when you pump waves through the material. The density of the material correlates really well with the speed of sound. And this tactic is used to identify different materials, and this is how you do it in material science. I wish I'd have looked that up beforehand, but anyway, someone has gone away and actually done the research of pumping sound through lunar rocks and different cheeses and different rocks and comparing them all.
Oh, good. That's what we pay our scientists for.
And here's the shocking thing. It turns out when comparing how fast sound travels through the materials, lunar rock is closer to cheese than it is to earth rock.
Wow, that's surprising.
So they looked at, here are the cheeses and their origins. Münster from Wisconsin, Emmenthal, Swiss, Cheddar from Vermont. Why Vermont cheddar? I don't know. Romano, Italy, Provolone, Italy, J-Tost, Norway, and Sapsago, Swiss, and these are all hovering between the 1 to 2 kilometers per second, and then they pumped it through two different lunar rocks, and that was 1.25 and 1.84 kilometers a second, so those are all relatively close. And when they looked at different types of rocks on Earth, they looked at granite, which is about 6 kilometers a second, they looked at marble, again 6 per second, they looked at sandstone, that's 4.9, so it was significantly quicker going through Earth rocks than it was going through lunar rocks and through cheese. One of the reasons for this is because cheese and lunar rock are quite porous. Porous meaning is kind of full of caverns and little voids. So, lunar rock is closer to cheese, but we need to take a step back from this and realise that we are only comparing this to rocks that we have taken from the moon's surface, and this is a point made in one of the critiques of the paper. So we're looking at lunar material that has been taken from the top layer of the moon within the first metre of the moon's surface. And the moon is covered in craters, and it has had a very violent history, and all of the rocks, and I mean virtually all of the rocks on the surface of the moon, have been broken up and reformed time and time again over the last God knows how many billion years. Well, 4.5 billion years, because I looked it up before. These rocks have been broken up and reformed, and this breaking up and reforming makes it more porous over time. Therefore, if we were to dig down way into the moon's surface and pull out a proper rock, just like granite, or just like marble or quartz or dolomite, some proper rocks that have not undergone this breaking and reforming time and time again, then we would have a truer sense of what the speed of sound would be propagating through these rocks when they were first originated, rather than having broken up and reformed time and time again. So this selection bias has led to scientists confirming that, lunar rock is actually closer to cheese than it is to Earth rock, based on bad sampling.
Okay, so it's not actually they were walking on cheese.
Unfortunately not. That would be brilliant, and I wish I could sit here and say that we've done it, we've finally proved it, but until we can get a decent chunk of the moon's core, or a very deep, honest-to-God moon rock that has been originated and not broken apart and reformed time and time again. Until we get one of those rocks, then we can prove that the moon is not made of cheese. But until then, we have to just use our common sense and say the moon is not made of cheese.
So it's still one small step for man, but not one giant leap for Manchego.
Ah, brilliant. I had absolutely no idea what cheese you were going to use for that quote. And as you were saying it, my brain went into overdrive. Like, you know how when your computer has to do some processing and you hear the fans going, that's what my brain was doing, thinking of what cheese is he doing? What cheese is he going to use?
Well, now you know.
Manchego, brilliant.
That's it. I can quit. That's it. Moon show's over. It's peaked.
Order! So we're on to PriMOOnisters Questions, where you guys ask us some questions about the moon. This first one comes from ShortStack on Twitter, and the tweet is, as there is a distinction between a gas giant planet and a rocky terrestrial planet, at least within our solar system, are there any gas giant moons out there? And the answer is no. There are no gas giant moons. And the reason is, the moons don't get big enough to become a gassy giant moon. So if you look at the likes of Jupiter, it does have a rocky core, but then the vast majority of its radius is mostly gas. There is still a big rocky core, but that is between thousands of kilometers of atmosphere of gas. But with the moons, they don't get big enough to be called a gas giant. So Titan has a gaseous atmosphere, but that atmosphere is only a couple of kilometers above the surface of the moon, so you couldn't really call it a gas giant moon because it's mostly rock with a little bit of gas around it. And the reason why they don't become gas giants is because they don't really get the opportunity to become a gas giant. So a moon will be orbiting a planet, and the planet will have a greater gravitational influence over the moon, so therefore it will steal the resources before the moon gets a chance to form its own atmosphere or get big enough to create its own atmosphere and hold on to it. We mentioned before about gas leaking out from the surface and atmosphere escaping the planet, and without anything to replenish it, it will just float off into space. Well, because the moons are smaller than their parent planet, they don't get a chance to hold on to the atmosphere. Some moons like Titan do, but when it's right next to a gas giant like Saturn, you're going to call Saturn the gas giant and Titan just a moon. So one of the exceptions to this could be a binary gas giant system. So you know you have binary stars, which are two stars orbiting one another because they're similar masses. You could get this with two gas giant planets that are orbiting one another, and if one is smaller than the other, then I guess you could call that a moon. But it wouldn't be a planet, it would be a dwarf planet because it doesn't clear the neighbourhood, which is one of the clauses it needs to become a planet.
So the bigger planet steals the gas of the smaller moon.
It steals the resources it would need to, one, get the atmosphere, and two, become big enough to hold on to the atmosphere.
It's like an aggressive StarCraft player.
You're going to have to explain that analogy to me because I've not played StarCraft. Played Age of Empires. Is that like going in and stealing someone's sheep?
Yeah, it's on StarCraft you're fighting over gas and resources. So it's a very niche joke.
During the height of lockdown, me and my group of friends were playing Age of Empires quite a lot. And one person got quite good and started playing competitively online. But there's certain etiquette, and it is considered very foul play to go into another person's village and steal their sheep. So he would just go in and just slay them all because then no one can get the food, and was just immediately kicked from the games.
Oh, right. Is that why is that against the rules?
It's because...
Is it not a war game?
It is a war game, but it's
just gone too far.
Oh, yeah. So killing all my villagers, that's fine. Stealing my sheep, no.
So why is that out of order?
I think one of the reasons is because you have something called a build order, which is the most efficient way of rapidly expanding your society and getting the most resources from the minimum starting point. point. So you each start with a couple of sheep, a couple of trees, a couple of villages, and it's just about maximising those very few resources. I think it's perfectly fine to just go in and kill someone's sheep, but apparently it's just a big faux pas, and no, you don't do that.
Oh, right.
I guess it'd be the equivalent of going to a chess tournament and blasting Cardi B in the other player's face. Even though there's no rule against it saying you can't play obnoxious pop music at your opponent, it's pretty bad to do it.
Well, I think you can't distract your opponent. I'm just thinking that this is a war game, you know. If you can do anything in war, that's it.
Yeah.
No, because I remember playing Age of Empires and thinking, yeah, this is just a boring version of Warcraft or StarCraft. And now you've just cemented that in my mind.
Oh, okay.
You're even banned from stealing sheep.
Well, I don't think... You're not banned, it's just in this particular competitive environment, it was just considered a no, you can't do that.
Yeah, that's lame. Because in Warcraft and StarCraft, you can go and harass the other people's villagers.
Yeah, that's fine. You can harass the villagers. It's just the sheep. No.
Yeah, while they're chopping down a tree, you can just hit them with a sword, and they'll keep chopping down a tree. They won't bother.
Oh yeah, they're pretty focused.
Yeah, that's it.
Oh, so sorry, that's why you can't get gas giant moons. Yeah, in summary, you can't get gas giant moons because the moons don't have the opportunity to become gas giants. The resources are taken from them in the early development stages of the planetary moon formation, also known as the protoplanetary disk. So the resources go to the planet rather than the moon. So on to the next question, which comes from Neil, and it's about the dark side of the moon, and he asks, does the moon rotate, and is the dark side of the moon in permanent darkness? Now, we've spoken about this and answered questions similar to this in the past, but this one I quite like just because it kind of reiterates the point, and it explicitly asks, is the dark side of the moon always in the dark? So, the moon does rotate, and it rotates once every 28 days. Because if you think about it, the moon is tidally locked, meaning we see the same side of the moon all of the time. Which means when the moon rotates once around the Earth, the same side is facing us, it has to rotate on its own axis during that orbit. So imagine me stood in a playground and you doing a circle around me. If you were to face me the entire time looking inwards at me, you would have to turn on an axis to make sure that you were looking at me during that rotation. So the moon does rotate, it just doesn't seem to because it's over a slow period of time, and also we see the same side, so it's not really intuitive to us from our point of reference that the moon is rotating, but it is.
Sorry, on that example, I was going to say, imagine you're at a barn dance and you're swinging your partner. They're always facing you, or at some point they must have their back to the band.
Oh, that's a much better example, yeah.
It's interesting how we go to different examples. Very, very obscure.
Yeah, prefer yours though.
If you've got a better way to explain the moon and its rotation.
Yeah, send us an email if you do.
What's your example? We've had barn dances and playgrounds. You can't have them.
So the other part of the question was, is the dark side permanently dark? Well, not permanently. So if you think about an eclipse, the moon blocks the sun, so therefore the dark side of the moon will be illuminated during that eclipse. And also, when the moon rotates, or when the moon orbits us, it will pass the sun eventually, so it will be illuminated. A lunar day lasts 28 days, and so 14 of those days are in daylight, 14, like a certain part of the moon, 14 of those will be in daylight, the other 14 of those days will be night. Earth days, I should say. We'll come on to this in a minute because there's another good question about lunar time. So hopefully that answers the question about the dark side of the moon. Funnily enough, that you should mention parts of the moon being in permanent darkness because there are actually certain bits of the moon that are in permanent darkness, and these are craters on the north and south poles where the rims are at such an angle and they're at such a point on the moon that they will never see any sunlight and they will just be in permanent darkness because of the crater rims and shadows being cast over them. There will be parts of this crater that will never see daylight, and within those there could well be some ice, which will be a useful resource in the future. On to the next question, which comes from Daniel, and he has a two-part question. Which moon is the biggest moon of the solar system? And that one is Ganymede, which is 5,268 kilometres across. Then the next one is Titan, 5,150 kilometres, and then Callisto at 4,820 kilometres. And between those two moons, Titan and Callisto, is the planet Mercury, which is 4,880 kilometres across. So Titan and Ganymede are actually bigger than the planet Mercury, which is quite cool. But the other question that Daniel asks, which I quite liked, is which is proportionally the biggest in comparison to the planet that it orbits? Took me a while to just kind of come to the obvious conclusion, which is Earth. And the biggest moon in comparison to its planet is Earth. Because when you think about the next planet out, Mars, it has two tiny asteroid moons of Phobos and Deimos. But then you've got Jupiter, which is 140,000 kilometres across. And then Ganymede, the biggest moon in the solar system, which orbits Jupiter, that's only 5,200 kilometres across, making Jupiter 26 times bigger than Ganymede, whereas Earth is only 3.66 times bigger than the moon. So that's the obvious answer. But then again, there's lots of moons out there that orbit dwarf planets, that orbit asteroids. So if you take, for example, Pluto and Charon, Charon is about half the size of Pluto. But there is one that has the biggest moon in comparison to the object that it orbits, and that is the binary asteroid 90 Antiope? 90?
Yeah, good enough. Say it confidently.
Yeah, 90 Antiope. So it's the binary asteroid 90 Antiope. And we have just spent the last 5 minutes figuring out how to say this stupid word, and I'm going to pronounce it wrong for the rest of this segment probably, so please ignore that. But this is the biggest moon in comparison to the object it orbits, because it's a binary asteroid that are virtually the same size. One of the asteroids is 87.8 kilometres across, and the other asteroid is 83.8 kilometres across. So one is technically bigger than the other, so therefore that is the parent compared to the orbiter, and their overlap is like 99%, so one is only like 1.01 bigger than the other. So that is your answer of the biggest moon in comparison to the object it orbits. 90 Antiope, whatever. So this comes from Ewan on Twitter, and he asks, if humans set up a colony on the moon, how would time work? Would we continue to run the old Roman system, or would we have to develop a new one with new measurements for days, months and years? And a quick follow-up to that was, if you were born on Earth and moved to the moon, would your birthday change? I was looking at this and was like, I'm pretty sure there is something called lunar time. Currently, astronauts use something called universal time, or UT. So when something happens in space, it is to UT, which is roughly around GMT, Greenwich Meridian Time, and I think it ignores daylight savings because that depends where you are on the Earth. So universal time is set to GMT, and that is our current system of 24 hours in a day, 60 minutes, 60 seconds, so pretty standard. However, lunar standard time was proposed by Rudolf N.J. Drasima, and is now maintained on a website called Lunar Clock. So this is not put in practice, but it could be. And here is a breakdown of the lunar calendar. A lunar year consists of 12 lunar days. A lunar day is divided into 30 lunar cycles. Each lunar cycle has 24 moon hours. 1 moon hour has 60 moon minutes. 1 moon minute has 60 moon seconds. So there's a nice mix of lunar and moon there.
I do like the way it's just like, hours, moon hours.
There we go.
There. Moon minutes.
It's like Space Chance all over again.
Yeah, that's it. Throwback to Monopoly.
Yeah.
But also the 12 lunar days, that's a short year.
Well, remember when I said before that a lunar day lasts 28 Earth days?
Oh, right, yeah, good point.
So a lunar day is one rotation. So LST has some logic to it, and the moon experiences 14.4 Earth days of sunlight, followed by 14.77 days of lunar night. So therefore, the lunar day lasts 29.53 Earth days. Oh, so I was loose with my measurements before. That's how long it takes for the moon to rotate once on its axis as it orbits the Earth, 29.5 Earth days. So using that base measurement of 1 lunar day is 29.53 Earth days, the division of a lunar day into 30 lunar cycles, and mapping the 24-hour clock on this, you can then define a moon second as 29.53 divided by 30. So that's 29.53 Earth days, dividing it by 30 lunar cycles, and you get a moon second, which is 0.0 0.984 seconds. So basically a second.
That's pretty much a second, yeah.
So here is the breakdown. A moon second, 0.984 seconds. A moon minute, 59 seconds. A moon hour, 59 minutes. A lunar cycle, 23 hours, 27 minutes. A lunar day, 29.53 Earth days. A lunar year, 354 Earth days. Do you know what this is like? This is like converting pounds into euros at the moment.
Yeah, it's not even that. I think it's more you remember the shillings and like pennies, the 12 pennies into a shilling, however many shillings into a pound, like completely different.
No, these are so close to...
Oh, so yeah. Sorry, I see what you mean. You've just been to France as well. That's what's in your mind. I get it.
I'm being furious that it used to be €1.40 to the pound. But anyways, by the by. But yeah, these are so close. 1 moon second is basically a second. One lunar day is basically a month of 30 Earth days. So it's so close.
Do you have to have a leap bit? Because if a lunar year is 354 Earth days, it's going to go out.
Yeah, but this is their own time. This is just on the moon. This is how you convert between the two.
But surely their year has to add up to our year. You know, our as Earthlings.
No, well, remember that episode of Captain Scarlet where the moon seceded?
Yeah.
Well, this is exactly the kind of thing they'd use in it. Be like, screw you. They'd be like, it's the 12th of July. Well, it'd start off pretty close, but then 20 years down the line, it's like, it's not the 12th of July anymore. It's actually August because we're out by a bit.
Yeah, but surely their year is the same because they're going around the same sun in broadly the same time. So
on virtually the same moon minutes to an Earth minute.
Yeah, so they should. Do they have seasons?
Yeah, the moon has seasons because it's on a slight tilt, so it's going to get colder and hotter.
It's in their interest, otherwise they'll screw up agriculture.
Well, yes, all those plentiful moon crops.
Yeah. So they should incorporate, lunar leap days or something.
Maybe? I honestly don't know. I like the thought they've put into it, but I think adding in a lunar leap day would just add way more confusion to it. It'd have to be a leap week to kind of catch up with Earth, wouldn't it?
Yes.
By the way, they've proposed names for the months. As in, though, you get 12 lunar days, they've proposed a name for each one of those days named after astronauts. So Armstrong, Aldrin, Conrad Bean, Shepard, Mitchell, Scott, Irwin, Young, Duke, Kernan, and Schmidt.
Oh, brilliant. And those are the days. So day 1, Armstrong.
Yeah.
Yeah, I read that originally, thinking there were 12 days in a week. I was thinking, is Armstrong the equivalent of Monday? And everyone kind of, flipping Armstrong, got to go back to work. When's the weekend?
That would be Young into Schmidt.
Yeah.
Armstrong would be the worst day because that was just Monday morning until 2 o'clock.
That's like Monday morning for the equivalent of like a month of Mondays.
So the other part of the question was, would your birthday change? I personally think that is entirely up to the person observing it, because time is just a concept of, it's just a human thing that we made up. It's Gregorian calendar, it's just completely up to us. So if you want to observe your birthday on Earth time or moon time, it's up to you. Like, I've got a friend in Australia who, when it's my birthday, because they get midnight before we do, will say happy birthday, and it'll be 8 hours before my actual birthday. But to them, it's still my birthday. It's entirely up to you if you want to observe your birthday on lunar time or Earth time.
I'd probably pick it carefully, because if you go up to the moon and celebrate it every year, you're going to age faster if their years are about a week shorter. So you can get up to like pension age a bit quicker, and then you can slow it down.
I could retire back to Earth.
That's it. So there's your plan.
Okay, yeah.
This is why we need a leap week on the moon. Otherwise, people are going to be claiming their pensions. Bloody lunatics coming back here.
All right, you've convinced me. I'm all for the lunar leap week. So that is Lunar Standard Time, which is an interesting concept, although I wish they'd have some consistency between lunar days and moon minutes. But it's an interesting concept, and I'll put a link to it in the show notes if you'd like to see more of a breakdown and potentially donate to lunarclock.org so they can finally afford lunarclock.com. So that was PriMOOnisters Questions, and that was the show. Thank you very much for listening. If you have any other questions you want to ask, please send me a question via either Twitter. My handle is I'm a Lunatic, or you can just simply search for Sean Moondes, thanks to Radio 1 for popularising that, or you can send me an email at iamalunatic@gmail.com. Anything else you'd like to add, Rick?
No, thank you for listening.
Yeah, thank you for listening, and catch you next time. Honest Andy's Discount Moon Show!
Hey.
That was a good show.
Marvellous.